A very good evening to all of you who have joined today's session. On behalf of Atal Innovation Mission team, I welcome you all to another exciting session of the ATL Tinkerpreneur. For today's session on robotics and electronics, we have with us Mr. Drupal Shah from STEMpedia. He is the co-founder and CEO of STEMpedia, one of the most successful homegrown edtech startups of India. He has been closely associated with many ATL initiatives from time and again. He is part of the working committee of the ATL Artificial Intelligence module as one of the experts. And his company, STEMpedia, had also ardently supported AIM in various initiatives as innovation partners, like the ATL App Innovation Challenge held last year. Drupal is also an active ATL mentor of change and is associated with many ATL schools and its students. I now hand it over to you, Drupal. The stage is all yours.
Okay. Yeah. Thanks for the introduction. Thanks, Naba and ATL team. Okay. So just give a minute. So let me start this session and let me just take screen share. Is my screen visible?
Yes, it's visible.
Yes. Yeah. Hi everyone. All the kids there and the ATL community. A lot of ATL mentors may be watching this. A lot of parents maybe. So in the last few days, you must have watched a lot of sessions and may have done many activities on the 3D modeling, Scratch projects, and may have like different mentoring sessions and all in this Tinkerpreneur and this complete series. And it should be a very good use of your summer vacations and home, how you can make something maybe digitally right now, and later once the schools are opening, then you can make those things on in real world also. I hope you will be enjoying this summer vacation and you will enjoy this session also on robotics and electronics. We will be mostly discussing on what kind of robots are there and what can you do at your age, which you are watching in your near world. Like different small issues would be there. Maybe if you are living in rural area or in the cities, everywhere there will be like different problems or different things. And like as a human beings, we need to make the environment and the surrounding and where we are living a much better place. And technology is of course there, which you can and surely use to make them. Like just you can watch in this session, this technology of internet and like computers and camera and everything is helping us connected in this digital world during this COVID lockdown. Like otherwise it would be kind of literally a kind of break. We would be like not able to communicate between different parts of the world or two different friends at home, right? So how we have used this technology, that's what we need to learn, and we can help the society to make a better place. So let's start with the session, and I will be just starting with a small question. What is a robot? Okay, so yeah, just one another thing. I would be asking many questions during this session. You can answer them in the chat box, in the comments, and if you're watching on YouTube, there will be like a comment box where you can chat, and if there are any questions also, the ATL community will be like taking up the questions, which we can discuss little later. If you have some doubts or if you have not able to understand some concept, then feel free to ask any kind of questions. So it will be kind of we will keep this very interactive, and you can feel free to ask any questions. Okay, so this is the first question, like what is a robot? A very simple thing. You must have watched movies or watched different videos where you will be seeing different robots doing very amazing things, or maybe very stupid things in some movies. So just type in what all kinds of comments you come about with a robot. Let me just also see the comments which are coming out.
So Drupal, one of the student is answering that robot is a machine.
Okay, that's of course the first step in making our definition towards a robot. Okay, so robots are of course a machine, but what makes them little bit different than a machine. Nabha, you seems to be muted.
Yeah, we have another one, that robot is a machine like humans that work all things like humans.
Okay, interesting. You are the next robot engineer. Okay, you can surely make that thing possible. A lot of technologies and things we will be discussing. Yeah. Okay.
We
So
also have references from Iron Man in the chat.
okay, yes, that's what they are watching movies, and like Iron Man is, of course, like when I was a kid, of course, we used to watch these movies and all. Like they are our motivations when we are young, right? It's good. They are taking this kind of inspirations. Yes. Now it's dead. Okay. So robots are kind of you can consider them kind of virtual human beings or machines. Actually, they are, which can sense, like just like humans we sense using our eyes, like we see, we can listen from our ears, we can smell using nose, or like we can feel touch or temperature using our skin. So of course those are our sensory parts. Then we come to like what things we need to do after sensing this, right? We need to take this information, and then we would be processing it somewhere. So that's, we have a brain. Okay, so there we can make some computation, some decisions, and after the, like once the brain processes something, then what we will be doing is we will be performing some action in form of, like, let's say we have hands. Like if I am saving you, okay, you are telling something and I have just observed it, my brain processes, and I am needing to greet you, right? So that's what we are performing some machine which can sense, act, uh, based on the information which is available to that person and that particular machine. So here's a very simple kind of different. I hope you are able to see my screen, right? Is the connection proper, right? Okay.
Yes, yes.
Yes. So there's a. I hope you can see the screen. The slide title is manual versus machine versus robots, right? Okay. Yeah. So here, like I have taken a very simple example of how we pick or we farm coconuts. Okay, the example is simple. What we are like, you can see in the first image, a man climbing a coconut tree. He is like just like he's just climbing without any support, without anything. He's climbing. It's kind of like, we know like coconut trees can be as tall as 20 meters or even 30 meters, right? And if someone falls, it can be very injurious to their health. But we all love coconut, so someone will be farming for us, right? So uh, but why how we can make it much more easy, or we can make it less risky, right? Why we need robots? Robots are not just for Iron Man movies. They are much more for some real use. We will discuss little later, like what things you can make it. So okay, so coming to this example, okay, the case is we need to pick coconuts which are very tall, which are like hanging very top on about 20-30 meters. So what we can do is, like, as someone thought of, let's make some mechanical structures which we can support. Okay, like if we get like if someone needs to walk, some elderly person, we have a walking stick, right? It's a mechanical structure. So similarly, like here, if some, in the second image you can see a lady who is climbing the tree using some support, which is kind of some rods, and which is like, which is just kind of a mechanical structure. Then comes, and it is still not a machine, it is just kind of a structure. Then comes a kind of a first machine. You can see in the third image, like the person put some more wheels on the both sides, so it can like easily climb the coconut tree, which is usually kind of cylindrical in shape, right? And we have put a motor on it, motor or a kind of small diesel engine or a petrol engine, which you can put, and then you can climb, like that person will be sitting on it. So here comes the definition, like this is a machine which we have put in, but still this is not a robot. It is just controlled by it has, like you can see near the hands, there are some similar kind of vehicle gears like we have in our two-wheeler Activa or in cycles. If we press something, the engine will start and it will move up or down based on the condition. Now, what we can do further to make it a robot, or we can call it as a kind of an automation device or kind of a robot. So we need to add few more things to there. Like as we discussed in the previous slide, a robot can have some sensors, it can have a computation power, and then it will act. So we will need some sensors which can detect like what is the height of the where the robot is in the complete like the coconut tree. It is like at the bottom, or is it at the top? Is it close to the coconut it needs to pick? So okay, so this kind of different kind of senses we need to give to this. And of course a robot can be controlled by a man, or it can be autonomous. Different kind of like categories are there. We will not go into too much theory, otherwise you will get bored. We will just keep brief summary about this kind of things, right? So people can experiment this thing. I am not sure the fourth image, which is actually in use, it's kind of a prototype, which I think prototyping was also one of the session in this Tinkerpreneur series, like how you can design and prototype, right? So you will be also learning. So because before making something, we need to surely prototype. It's a complete process. It's not you can come out with the one solution in the first day and then the robot is ready, right? So, but surely, I'm sure in next 5 to 10 years, people would be using robots for different applications, like even household or like cleaning your home or different kind of things. Let's just repeat what we discussed. Okay. So here we have like, it is now in kind of a series, like an order, how things are done. So we first sense, then we plan, and then we act, just like a human. Okay. Like a robot has some vision or different sensors, then it has had a brain. We will cover this brain part in the electronics very briefly, and then we can do some actions. Now in the coconut example, we seen like different parts were there for a robot. So for the first thing, it should have some sensors. Like different kind of sensors are there for robots. Like there are light sensors, sound sensors, computer, like camera. A camera acts as eyes for the robot, right? And then we can have a few more temperature sensors, humidity or temperature, moisture sensors. A lot of things are there in this world. You can search on internet and you will be able to use a lot of things. Then comes the actuators. Like actuators are kind of which gives them motion, which is, let's say a motor is there, or a kind of piston is there. Pneumatics right now is used for some examples. Then is the controller, like which gives them the computation power. It can be like if you are from ATL labs, you must have observed like Arduino boards or Raspberry Pi or Revive or this kind of things, which are used to make simple projects. I'm sure you must have used in your ATL lab. And then is the structural elements, like which is kind of the body, which gives the body to the robot, where this all actuators or sensors or controllers are fit together at appropriate position, and you can. And of course, to power them, we need some battery or some power source. It can be like in the coconut example, it was a diesel engine or something. And on top of it, there is one thing which is not a physical structure, but a kind of a virtual thing, like programming or code. I think the last session was on animation, where you might have made some codes or something. We will be making something similar also. So program and the code or the It can be in nowadays in different form, like people make codes for artificial intelligence, machine learning, algorithms like line followers or something. We will be making where we will be going into details about how we can code. But why we need robots, right? So the similar, like you can again type some of the comments in the chat box, like why you think you will need robot, or if you think we do not need a robot, you can type in that also, right? So first thing is like they can never tire of doing things. Let's say if you are told to do a homework of, let's say, 5 pages or something, after some time you will feel tired. But if you power a robot with appropriate battery, it will never get tired. And of course, they will not get bored on doing the same thing again and again. Uh, if a like put a thing from one place to another for 1,000 times or 1 lakh times, it will not get tired. And they are, of course, many times they can be quick or slow depending, or precision also. Many times they have to be like very accurate. They have to particularly pick it at centimeter accuracy or millimeter accuracy also repeatedly. And like in the coconut example we saw, it can be like the situation can be risky or hazardous both. Like if we are needing to paint something, or like very high temperature welding or something, there also the situation can be hazardous. The second part was, I will not go into details about this too much, but let's just talk briefly about what is electronics. So electronics is like study of electricity, electrons, and everything. Like a lot of electrical and electronics appliances you see in your home around. Right from very simple thing, like right now you are in your mobile phone or computers, it is part of electronics. Or use TV remote or TV or refrigerator. Everywhere there will be some kind of electronics. And in your ATL lab also, you must have seen different kind of different kind of things like resistors, LEDs, Arduino boards, or fuses, or a lot of things. ICs, many types of them will be there. Right? So these are all parts of electronics, and the core thing which runs all these electronics things is either like voltage difference, which we call like with EMF or something, if some students can understand. And everything, like there are electrons and voltages and everything which runs them. Now let's take some time to discuss. Like I will not discussing a lot on the slide, but let's just type in. You must be living somewhere in the rural areas. Okay, sometimes you will be seeing, or maybe you are at your home, so your parents would be facing something, or your sister would be facing something, or whatever kind of things will be there. So just try to figure out and type what kind of robots you need in your real life, and what kind of projects you want to make something good, or to make even to tease your siblings or some friends, right? तुम लोग बहुत चीजें लाइक सोचते होंगे कि मैं ऐसा बना सकता हूँ, मैं वैसा बना सकता हूँ. सो जस्ट शेयर करो अपने कुछ आइडियाज, क्या क्या चीजें तुम बनाना चाहते हो रोबोटिक्स से रिलेटेड, और उसको कहाँ यूज कर सकते हो रियल वर्ल्ड में. ओके, सो कुछ इंटरेस्टिंग आइडियाज मैं जस्ट देख रहा हूँ यहाँ पे मैसेज में आ रहे हैं. ओके, ओके, सो सम एग्जांपल्स लाइक इंडस्ट्री में यूज हो सकते हैं. स्पेस में अभी शायद क्यूरियोसिटी रोवर और वैसा सुना होगा आपने. यू कैन यूज इन देन मिलिट्री एप्लीकेशंस, और यू कैन यूज इन हाउसहोल्ड्स लाइक क्लीनिंग योर होम. Transportations में like you must have heard about like Tesla, self-driving cars, and that. In agriculture also, we just saw about the coconut example you can use. And for, of course, entertainment, like different kind of, if you have you can surely watch this video of Ivo robot from Sony. That is a very cool cute robot dog you can see. Now let's come to the activity time. Since we are working all digitally, we do not have the kids around to play right now. If there would be like time when the schools would be there, we might previous year there was like Tinkerpreneur, Tinkerfest and all those things. You may have made something, but right now we will be making something virtually. We do not have the car right now, but how we can make it or how we can learn the similar kind of things virtually. Okay, so we will be making a line following robot. Okay, so let's start with the activity. In the email or in the information shared to you, you must have installed the software or the application PictoBlox, or you can just right now search on the Play Store about PictoBlox app. If you are on mobile phone, if you are on computer, you can just type PictoBlox.ai, which will be also messaged in the chat. You can
Before we move on, Drupal, I would also, as a user and as a viewer, I would like to know about this software. Matlab, what is based on? Matlab, as a user, I only know that it is Scratch based. So,
yes,
if you
yes.
would like to share with our students.
Sure. Yeah. I would surely like to answer this when I would be taking the demonstration, so that at the same time they can understand like how it is different or what are the good points and where they can actually use it along with Scratch or along with their Arduino boards if they have some kits around that. Right? I will be just answering that. Yeah. So in the meantime, you can just install the mobile application if you are on the phone. If you are on computers, you can type https:// PictoBlox PictoBlox.ai, and you will be able to open in your web browser. So let me go to PictoBlox. The interface is very similar to Scratch. You must have seen, right? There is like a title bar where there are some commands. There is a stage on which you can do something. Then we have a coding area, like where the blocks are there. We will be using some of the blocks from the control. It is just loading. Okay, yeah, fine. I'm just with, okay, fine. So also in this slide, the next step is, if you are on the mobile phone, you can scan this QR code. So a file will be opening in the PictoBlox app. If you are on computer screen, there will be a link which will be shared. This is the link, http://bit.ly/p capital small I small c TOR capital OBOAIM capital -v2. Or I think this link will also be in the chat. If you are in computer, a file will be downloaded. If you are on mobile phone, you can just scan this QR code and it will open in the app. I hope you are able to do. I'm just opening the file. Yeah, on opening this file, some of the models will be loading. So just wait for 2-3 seconds and it will be loaded. So what we will be doing is, we will be making a virtual environment where we will run our robot car. Okay, I hope a lot of kids will be able to do this so far, right? If you are facing some issues, you can comment in the chat. Yes. So PictoBlox is an tool for coding, which is very similar to Scratch, but we have added a lot of features for AI, machine learning, and like self-driving car, QR code, weather data, IoT, and a lot of things you can do with this, along with the basics of the coding, like in the Scratch. We will be also adding Python and few more things very soon. And also from the boards, like you have used Arduino boards, or like if you know about Wi-Fi IoT related boards like ESP or something, you can control them also. You can program them also using this block-based coding. Okay. Now let's first see what we want to do. So we have a car and we have put 3 sensors on it. In the front, there is one sensor, blue sensor at the center. There is one green sensor in the left. There is one red sensor on the right side. What we need to do is to follow this. What we need to do is follow this car on this line and come back here. Okay. So like here, the robot is our car. We have put some, now going back to the analogy, we have added some virtual sensors, which are this color. Okay. We have added this environment, which is this line. Now we will be the brain part, which was there, or the coding part, we will be needing to make here in this activity. And there will be like actuators. So based on this, there are like motion blocks with which we will be giving motion to this car. So let's first just discuss the algorithm. Very simple. It is very simple. If the car is on the blue, if this blue sensor is on the black line, it should move straight. If it is on the green, if the green sensor is touching the line, what we need to do is turn the robot towards the left and it will move forward. If the red sensor touches on the black line, what we need to do is move little bit right and move forward. And similarly, we will do this in loop, complete loop. It will be moving in this line. That's what is our task of this activity. Okay. So I hope kids are able to do this, right? If you are still facing some issues in downloading this code, you can, I am just sharing the screen again. You can open PictoBlox in the browser if you are on computers or laptop. If you are on tablet or mobile app, or sorry, in mobile, you can scan this QR code and a code will open and you can install the PictoBlox app. Fine. Okay. Or if you are not able to do, don't worry, this video will be there. You can watch it again and do it. Right. So now start that. So we have discussed what will be our logic. Okay. And many kids would be able also know like this basics of coding and this. So I will just try to introduce some of the things as and when I was doing. Okay. So I have just put the sensor blocks here, which will ease you during this activity so that we can complete this in stipulated time. Okay, so we have put this one block for when this blue sensor is touching the black line. The second block is for the green sensor touching the black line. And the third, we need to use as and when. I will ask you when we need to use them, right? So this particular block is like this one particularly. Just put this car in this original position. Like go to XY is like there is a coordinate system in this complete space. Like if I go to 0 or 0, 0, it will take to the center. Now, like you know how in the graph things are, like this is the x-axis and this is the y-axis. Okay. And now if this is the position, it will be some positive x and some negative y. So you can see positive 90 and minus 110. Now let's add a forever loop. So what this we need to do is we need to complete this complete action, like checking the conditions is blue on blue sensor on the line, or is the green sensor is on the line, or red. Continuously we need to do, and then we need to move the robot accordingly. Okay. So let me just start. So I have like snapped this forever block. You can find this forever block in the control. Now what we need to do is we need to check the conditions. Okay. So there are some blocks called conditionals. So I think you have already used them yesterday if you have watched them. So we will be using this if block. Okay. Or we can use this if and if else block. Okay. So what this block will be doing is, if it will check some condition, if the first condition is correct, then it will do some action which is placed here. Otherwise, if that condition fails, then we need to see the second condition. And we can add multiple if and if loops. You will just see how we can do it. Okay. Now, firstly, we need to, since the center sensor is this blue sensor, so what we need to do is we will place this in the if. And there are like different kind of things. We will, like this block, what it will report is, it will report, you can see right now this car is on the, this blue sensor is on the black line, it is reporting true. If I move it outside, it is giving false. Similarly, the same, this blocks will also do. So these are actually kind of conditions which will just say like if this color is touching this black line, then we need to do some action. Then what we need to do action? The action is move the robots towards the straight, like in the straightforward direction. And we will type in 2 here, like 2 steps for this forever loop we will be doing. I hope you are able to follow the steps. Okay. Now, let's just test. And a very interesting thing we need to, while making this, okay, we need to do, we need to make this code in fragments or steps. Like we need to divide the complete process in small parts. If we make it completely like in one step, things may not work, and we may be lost somewhere that things are not working. The parts, just try to run. What happens? You can see this car moved a bit, but it stopped when the when the blue sensor lost. Okay, so now what we need is again moving. Now what we need to do is we need to again like add an if condition. If the green sensor is touching the line, then we need to turn a bit, and turn towards which direction? Like here, towards the left direction or anti-clockwise direction. Okay, so we have added this condition. Now let's see what happens when we added this direction. Oh, you can see this car is now following the path. But now the red sensor is touching the line and the other two are not touching. So what we will need to do is add the another condition which will check for the red sensor also. Okay. Now let's which direction we need to. Okay, the car is turning fine so far. Here you can see since the red sensor is touching, it is moving the other direction. And you can see the car is comfortably able to turn and move. Okay, you see like it is going in the loop. Okay, fine. This is the first step which we have done. Now let's say, suppose if you want to stop this car at this particular block. Okay, so let's what do is we have just started from this position, and once the car is coming to this position, we need to stop it at the same point. Are you able to follow this code? You can ask in the comments if you have some doubts or if you are facing some issues. I will try to help you and make this code. So if you are on phone, you can there is a small at the right top, there is a button to hide and unhide stage also.
Drupal, a few students have a doubt of how to get the theme. If you could once again show
Sorry.
the theme
Sorry.
that you have, the theme that you are using.
Okay, this environment. Okay.
Yeah.
Yes, yes. Okay, okay. Yes. So, Napa, if you can again try to message the link to the students. So what we have did is we have made a file like as the starting step for the kids. The kids can either scan this file and then they will be able to download the environment which is used in this particular code. Okay. Or you can, if you are on computer, you can just download from this link. The link is, I think, in the comments. You can see. Okay. Okay, and if you can just type in again also so that kids can copy if they want to again
Right,
try
I'll
it.
do that.
Okay, yeah. If you are on computers and if you still wants to do it on your phone, you can just scan this code. It will be very easy for you. Uh, we have this very simple code we are just making. But we wanted to understand how the logic thing works and how we can actually use this block-based coding or something for making a robot. If we had hardware, then also similarly you need to code. You can go to this boards and you can use Arduino boards or something, and from then you can conditions. Just then what we need to do difference is in place of this move blocks, you would need to add some blocks to run motor. So then your car will be moving in real world. This is the link. I will just try to repeat also the similar steps if you are able to do. Are you able to? So the first step should be open PictoBlox. If you are on computers, open PictoBlox.ai in your browser, like it can be your Chrome browser or it can be your Safari browser. The next step for computer users should be go download this link, the file which will be downloaded from this link. Then what you need to do is open, like I am right now doing it. Then you need to load the downloaded file. I have like already downloaded the file. So once you load, you will be able to see this environment already loaded in your computers or in your app of PictoBlox. Okay, so let me just try to repeat the steps again. On the algorithm, how we can control this car so that it can move within the line. The first step is we have added these 3 sensors on the car. I hope you can see, right? We have 3 sensors. We have put it on the robot. This blue sensor, green sensor, and red. Now the condition which we will be putting in is if the blue sensor is on the line, then we need to move straight. If the green sensor is on the line, we need to turn a bit left. If red sensor is on the line, then we need to move right. So like it will be kind of see, and you can also see like if someone tells you to ride a cycle on a straight line. Okay, this situation is very simple, right? Okay, so how you will do is, like if your cycle is going little bit off the lines toward left, you will be just trying to steer it with your handle and you will move in the line. Similarly, we will do here. And on using these blocks which are provided and using this, we are able to make this code. If we run it, you can see this car is moving. And your homework would be like, when this car comes to at this stop, how you can stop it. Okay, so after this session, try and add some kind of logic which will stop this car when it is coming at the when this car is coming at this point. You need to stop this. You can also type the answer if you can figure out how you will add some kind of conditions. If you know a bit of Scratch or coding, you will be knowing like there are some kind of operators like which are kind of conditions with checks like and or conditions. I will just take a minute to explain you this. So and is a condition which will check both the things which are put in this two darker slots. Okay, so if you put, let's say, this thing okay here, and if you put this thing here, and now if this is thing, so if green sensor is reporting yes, here you can see this block is reporting false because both the conditions are false. If you put here, this is the or condition. I hope now it will be better visible. Now you can see it is showing true because one of the sensor is on the line. Again, also since red sensor is on the line, but if we put blue sensor, it is giving false. So this kind of logic we need to add while making our robot, and a lot of complex codes are written to actually make some robot function. Okay, now you can try to relate it with the coconut tree robot example. A lot of things would be happening in the robot itself. Is it at the bottom place or it is at the top place? It is near it needs to pick some coconuts, or it need to cut the small stem of that. A lot of sensors would be using, and you need to put a lot of conditions, you need to put a lot of controllers and like things there so that your robot functions properly. It takes time also. Don't just feel like in one day you are able to do or something. Next, I will be giving you a small demonstration how PictoBlox is different and how we can use it for a lot of AI related features. Okay, so let me just hide this car, and I will also turn off my video from for a few minutes. Just give me a minute. Just give me a minute. I'm just trying to turn off the video. Just wait a minute. I'm just trying to stop the video. Let me just stop the screen share and check video. Just a minute. This option was not visible. Okay, fine. Now let me again do the screen share. I hope you can see my screen. Okay.
We are able to just see the PictoBlox screen only.
Yes, yes, yeah. So here you can see we have made a little bit longer, little bit longer code in which what we are doing is we have just give me a minute. Yeah, let me load the file again. So what now we are going to do is we will be controlling this same car robot using our face, like something kind of AI, which is like nowadays a lot of people are talking about you AI, and you have this ATL in step up module and this AIM module for AI, and a lot of sessions may also be taken at your school, or it will be taken in coming few days, right? So we will be just discussing. Just give me a minute. I think the camera is not loading properly. Because of this. Yes, now I'm able to load. Sorry for this small glitch. So we will be like trying to control this robot car using our face. Let's say if I turn towards the right direction in the screen, the robot will turn right. Okay, now let's just open this, and you can see the video. Okay, right? So now the things are set up. Sorry for the glitch. Okay, so what kind of thing we have written here? So what I have did is I have already made this code, which you can also run, and it is right now moving. Okay, so I will just take you to the few steps which we did. So this was the code which we made few minutes before. Now what I did is I did, you can do this thing little later. I will be just demonstrating you right now. So we added, there are different kind of extensions. We can do like either face detection or like detection of human body parts detection using your hands, head, body, legs, or different thing. You can also do the similar kind of thing using speech signals. Like you can say, move robot forward. It will move the robot forward. If you tell it turn right, it can do turn right. So a lot of different ways you can do, and all of these possibilities are there in this tool, PictoBlox, and you can use it. Okay, so going to this demonstration, what I'm seeing right now, you can see if I am sitting in the center of this stage, the car right now the code is not running. If I go towards the right direction, the car will turn right. If I go in the left, it will the car will turn left. Okay, so this code you can see right now, since I am in the center, you can see this condition. This car is going in the straight direction. If I am turning in the right side, you can see this box which is showing a human face is there. If I am coming back, it is moving again in the straight direction, but it turned a bit. Now, if I am going in the left direction, you can see it is turning on the left. And now, this is a very basic example of how you can even use AI to move your robots and do a lot of different things using PictoBlox or coding or robotics. Okay, and there can be different kind of real life applications where you can use this kind of things. Let's say, suppose if some person has some disability and he is not able to like speak or something. So what he can do is like like he can show different gestures using your hand. Let me just try to show it a bit. Okay, I will let's not go there. Okay, so you can give like different kind of hand positions, if you can show different kind of things, and you can communicate. So similarly, you can communicate with different kind of gestures or body expressions and things with which you can control your robots or make them much more interactive, or it can like do different kind of things in real world. Now let's go. I hope you will have enjoyed this. You can watch this again after this session if you are not able to do it, and you can complete it. And your assignment was to stop this car on the track on the black spot. Fine. And now let's turn off the camera so that I can turn it on. Okay, cool. Fine. Okay. And so I hope you are able to do this activity, and you can repeat it again, and you can explore it in much more detail. So here is the small example how you can like we see right now in the video. I turned at different places, and you are able to control the robot. Here, what you are doing is you are doing different gestures, okay, like hand gestures, and you are controlling this Arduino based robot. So okay, like you can again do this later when your schools are open in your class, or if you have Arduino kits at your home. Okay, with which, and I think this activity is very mentioned in the detail in the AI step up module. You can search on the internet and you will be able to find it. Okay, or you can ask your ATL in charge in the school, they can help you. Okay, so these are like simple activities which you can make, but application wise, there can be a lot of real world things. But of course, we start with very small projects at the first. Okay. And now, of course, there are different artificial intelligence related things which are already mentioned in the step up module you can explore. Here is a small video. We will just spend a few minutes just to, you can watch like what kind of things a real world robot can even do. Okay, so this is from a very famous company like Boston Dynamics in US. They can they have made a complete human-like robot which can do a lot of complex things which a human can do. It can dance, it can walk, it can do anything. Okay, and there are different kind of things. They have made kind of a cheetah, like a dog-like robot which can do. You can see. Okay, you can watch this video later. You can search Boston Dynamics robots on Google or on YouTube, and you will be able to find it. Very funny things and very interesting things they have done it. Okay, now like we have done a lot of things. We have covered some theory, we have made some activities, but now a very interesting questions many people discuss, and you can just like right now you have seen in movies, in some of the movies, like robots are like competing with humans, or they are trying to beat humans many times. So when making this kind of technologies, or when you use this kind of technology, you have to be very cautious that they are used for some social good. It should be kind of used somewhere so that someone is benefiting positively from it. Okay, so you can try to answer this. What do you think? Will robots and this artificial intelligence, which we see like a lot of things we can do is using speech, vision, computers, and all. Like you might be thinking, like everything a human can do, a robot or an artificial intelligence device or something can surely do. So what will happen to humans? So this is a very interesting questions right now, and of course very interesting answers, and people should be very carefully using this kind of technologies, and they should be using it for something good. Okay, that you need to be very carefully using, and you need to be good human being with which you can use this. Now I will be like giving some of the small examples. Like right, we made a virtual uh, line follower. Okay, so how you can make something on we did. Okay, just give me a minute, and I hope you can. I'm turning off my screen share so that you can see this video very well. Here you can see like the arena is very simple, which we used uh, during the like the environment which we used, and here you can see how a robot is following the same thing. Like there are two we have like kept two LEDs on the top. You can see one, like we have kept two LEDs, and they are changing their colors. Like when the sensor is on the, like you can see here are the two sensors which we have used, and they are following the line very similarly what we did in our virtual activity. here you can see now, since the robot is turning in one direction, you can see one LED which is like sensing this line, and when it will be coming to this location, see the difference what it will be doing. Okay, you can see now this particular LED is blinking, which is showing that this sensor is detecting line. Okay, so and this particular thing is called simulation. Like what we did firstly in our virtual environment in PictoBlox is now actually repeated the similar way, exactly similar way. Here you can see, but of course, like real world and virtual world are a bit different. So we do a little bit more complex coding also. We need to control the speed of the wheels and a lot. Like in the simulation world, it was very easy, like move 2 steps. But here you need to do different things. Okay, so this type of robots you can make in your ATL lab also, or if you have like those kind of things available. Now we will be showing you like you just scanned a QR code few minutes before. Okay, so also like there you can, what you can do is you can see like we have put a QR code on top of a robot. It is little larger QR code, but now what you can do is you can find the orientation of the robot. Like suppose this is your arena, okay, and what you can do is you can find this like okay, this is standing like pointing towards the down, this is pointing towards the up. So your QR code can also give this kind of information with which you can figure out where your things are going. So vision, like this computers and this cameras are very powerful tool with which you can control these things. And also we have put a ultrasonic distance sensor, many of you might have seen in your labs, to detect some of the object which is coming in place, and you can detect or you can grip and like you can do different kind of things using that. Okay. The next we would like to show is like kind of a somewhere like firstly in the first robot we see how sensors are used. In the second again we used how a computer can be used to analyze the position and track the robot. Now in the third thing we will be seeing how a robot is like we can make few mechanisms and structures like you can see here. Okay, so like robot has different parts like sensors we discussed, then we see about actuators, then we discussed about the controllers, then we discussed about code. But one part which many times we miss is called physical structures or the mechanisms, those things. That is also very important because making a robot move is not, it's not the end. What we need to do is like it gives some kind of particular motions also, and how we can do particular task. Let's say if we need to grip this small box, okay, we need to put it somewhere. Like this was like in the one robot you see how we can pick it, how we can grab it, but it is not able to pick it. Okay, so if we need to pick it like you have you see in your crane or this kind of thing, we need to make some particular links and physical body physical structure also. So here one thing is called we have used is called 4-bar parallelogram mechanism. Like you can see you can just these are little bit actual university level robotics things which people see, but you can also use them in your projects if you can ask your teachers or mentors in your school. So what this can do is this will go inside and this will grip it. You can see now it is gripping and it can move around and it can come back and it can drop and it can come back. So this mechanical structures, many times people miss this concept. Like robots do have mechanical things. In the coconut example, it is a very good example where you can observe like to climb a tree, you need a different kind of, it's not just your wheels cannot work there. You need to be very specifically using a particular user like a case specific or a task specific mechanical structure to use. You can see like this is another steering robot. Like you have like when I was a kid I was very fascinated by steering and this can, so here you can see like a 4-wheel steering robot you can make. And like one application we see in the when we are discussing about applications was a space rover, or many times many kids are very fascinated about space and those things. So and you might have heard of the name Curiosity rover. So you can even make some complex things, and here you can also sing. See, like a bit of complex structures are there, and it can even, like, if this kind of object is coming in top of it, it can climb. And we had actually less time, so we are not giving you the live demos of everything, but it can even climb and it can go on top of it. So this kind of complex structures, of course, they are like baby models of the real world thing, but that's the starting point for you to start learning. And I think I've done with the time is also complete. So if you can ask very interesting questions where you have like what all things you have learned, or if you have uh, particularly missed something, feel free to ask and comment anything you want to know further. The AIM team is very supportive, and they will surely help you arrange some sessions for different topics which you want to learn. So I think Naba, I'm done with my things. Like now the question answers we can take on.
Yes, yes, Drupal. Thank you so much for such an interesting and engaging session. I would like to know, we are talking about the Tinkerpreneur Bootcamp. So do you have any suggestions or any advice for students? What projects can they take up?
Okay, yeah. Now the more like for this question, the most students which like we also, like I'm a mentor, so many students ask is how we can virtually do things because the things are not there. So the answer is a little bit biased with the at home learning thing. Okay, so the particular concept of this Tinkerpreneur from as per me is how we can ideate something or how we can come out with some ideas. If the solution may be working fully or if it may not be working, it is fine, I think so. But your approach should be very much important to make some kind of solutions, whichever you see in your close vicinity. तो आपके आसपास में बहुत सारी चीजें हो रही होगी लाइक यदि आप रूरल पार्ट में हैं तो बहुत सारी एग्रीकल्चर रिलेटेड बहुत सारे लोग बहुत डिफरेंट चीजें फेस करते हैं लाइक आई विल जस्ट ट्राई टू गिव अ लिटिल बिट एग्जांपल हियर so we did some programs in rural parts near Pune with Fiki and like some organizations. So the kids were from rural background, and what they did is like that kid was actually he took this small robot and he wanted to make a agriculture like smart farming thing. So what he did is he didn't have many parts. He just had this small robot. So what he did is like एक ट्रैक्टर में क्या होता है उसको एक स्मार्ट ट्रैक्टर बनाना था रोबोट. So what he did is कॉम्ब लिया लाइक जो थोड़ा बड़े लाइक क्या कहते हैं उसको आई कैंट फिगर आउट बट लाइक कॉम लाइक कंगा लिया जिसके थोड़े बड़े लाइक जो भी होते हैं उसके जो टिप्स आई थिंक टिप्स ओके देन दैट ही पुट ऑन द रियर साइड so that that can act as a digger like जो मिट्टी को खोदने का काम करेगा. So and on the front side he put a pen जिसका आगे का उसने रिफिल से मतलब नोजल आगे का निकाल दिया लाइक आगे का जो कॉनिकल टेप होता है और उसके अंदर सीड रख दिए. ओके and now he was like on a floor he took but since this robot is like little bit मतलब ये एकदम मिट्टी में नहीं चल पाएगा तो उसने क्या किया एक कंक्रीट मतलब ऐसे ही घर के बाहर एक जहाँ पे भी थोड़ी फ्लैट सरफेस होगी उस पे मिट्टी थोड़ी थोड़ी रख दी टू शो इट एंड देन ही टुक फ्यू नीम लीव्स विच उसमें थोड़ा सा मिट्टी गीली करके उसको ऐसे पौधों की तरफ ट्रीज की तरह उगा दिया. आई डोंट नो आई डोंट हैव द फोटो बट आई कैन शेयर इट little later. But that was a concept which he tried to show with whatever things he had available at home, like Kanga, pen. These are like I'm just giving some example with which he very creatively tried to think of what all his like a smart tractor. Okay, if we google on smart tractor some very big jumbo things will be there. Okay, but that's there. What we need to do or what you all guys can do like आप आपके एज पे किस तरह से छोटी छोटी चीजें आपके पास जो अवेलेबल है और या फिर उसको वर्चुअली किस तरह से कर सकते हैं.
Like right now, we just did and showed you some activities which you do virtually in using coding, like PictoBlox or Scratch are very good tool for you guys to like explore things and do things in simulation, or you can make a lot of projects using AI. Like MIT App Inventor is there with which you can make apps, and like many creative things are there. You just you follow all the sessions which are taken by this in this series. You will know a lot of things during your summers. Okay, so don't feel like you do not have the kids, you cannot do anything. Okay, like best thing is like be exploring things which you can like think on, try to figure out ways how you can do it. Like इट डजेंट मीन कि हर चीज में ऐसा पैसा लगाना जरूरी है जैसे किट्स मिलेगी. If you are close to your schools nowadays, you can even ask some of the teachers if they can help you to arrange that kits at your home. I don't know how is the possibility of this thing, but it may be possible. You can find a lot of resources, and your ATL in charge can help you also with this.
Thank you, Drupal, for sharing such a wonderful example. And सादा लफ्जों में कहें तो creativity और innovation, like you said, कभी भी resources नहीं होता, and especially in a country like India, in our country. So yeah, so students, today what we have tried is to show you something over and above that is already available on the Tinkerpreneur portal. And like Drupal has already mentioned, this PictoBlox software is an open source software and completely free to use and free to download. So you can come back anytime at your pace, download the software and follow the steps, and yeah, get started. Drupal, thank you once again on behalf of AIM team for joining us today for such an engaging and interesting session. And again, to the students and teachers and the mentors as well, I invite you all to an equally exciting session on cybersecurity tomorrow, where experts from WNS will be joining us. So for now, we are signing out. Thank you so much for joining us today.
Thank you. Yeah.